How's it going, everyone? Welcome, Eulio Gonzalez here. And today let's going to explore now about the string behaviors, the primitive. We're going to walk through the type system, which is one of the pillars of JavaScript, and why we need to take a look at this particular pillar as a way to understand how now JavaScript works, which is the mechanics of this. So we have now the type system, one of the pillar, the scope system, as well as the object systems. So first thing first, thanks to Kyle Simpson to actually make a particular books. He's the author of a series of books to dive deep into this particular topic, especially on the series of You Don't Know GS. Is not an attempt to offend you, it's just to show you things that you might not know, and it is important for you to understand if you're going to use this tool so we can be very effective and efficient with this. So we are only focused about is ECMAScript because there are other areas that are relevant, especially for the asynchronous nature of JavaScript, which is relying on a lot of these internal tools that is provided by the host environment, aka the browser, all right, or any other environment that allows to run JavaScript code. For example, Node. And how, in the case of the asynchronous nature, we have, for example, the callback. What is a thunk? What is a promise? What are the intrinsic nature of the promise? Where the promise came from? As well as what is a generator? How can we create a generator? What is the role of a generator? And also to understand the way of how you can recreate the async and await using now a generator to understand the mechanism behind the scenes. And some advanced topics of concurrency, which is working with now the libraries like observables, all right, which is still now a proposal on the language, observables. And now with observables, how can we now deal unlike with promise, with handle is just one single event. If you need to handle a series of eventual values, all right, you can do that by listening to the source. In any time a particular item you pass through this channel, then you're going to now get that, apply some sort of transformations if you need to. If it's not, you're gonna let them pass through. So with this series of eventual transformations, it allows you to now pass like an event source, right? You have the source, which is now transmitting all of these events over the channel, and how now this is something that is passed through a series of transformations to get a desired outcomes. Now, we look at libraries like RxJS and concepts like subjects and how you can create your own observables and how now by creating your observables, aka the source, you can go is with primitive as well as with array-like collections and promise, and also with observables in itself, and how you can handle each one of those cases, whether it's with primitive or with these more observable objects or complex objects, such as promise, generators, and even observables, all right, to handle those cases. And then dive deep into what is the observables and how you can create observables and so on and so forth. Now, because of that, all right, in something called now the concurrency channel, CSP programming, especially CSP programming, okay, that might go beyond the scope of this, The communicational sequential process is a formal language for describing pattern of interactions in concurrent systems. All right. Again, that might be beyond the scope of this. Okay. However, it is important at least to understand that this is not the frontier in which we are going to handle. So, for example, programming language like Go actually make use heavily of this, and how they handle now the concurrency is heavily influenced by communication sequential process. And I think that I will take some courses later on, right, on Go and how to deal with the concurrency, because I think that'll be a good way to look at that. You know, interesting. Hmm. 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 Oh, he published, okay, several books on that. Okay. He published several books. Interesting. Interesting. Oh, he published several books to that. I get it. I get it. Hmm. Hmm. Okay. So, but again, I get there are a couple of stuff that go beyond the scope of this. All right. Hmm. 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 But that's not the way, bro. I will always go for what the market needs to. I will go for always what the market needs to. Now, good. Yes. Yes. Now, but in this case, we're going to now is recap about the fundamental of the JavaScript, especially to explore now these particular pillars, the type system, what it is, and how do we get here. So first thing first is to understand now the type system, which is made of the primitive as well as the objects like. The type operators as a way to check is the value of a variable or the values type, and it's gonna give you as a string some of the corner cases with this and the kind of emptiness. All right, so you have now undefined, declare, and initialize. What is the difference between each one of them? And some of the empty values, so for example like null and undefined are nullish values. Check for to put it here. As nullish values, right? And how now we look at some of the operators that allows to identify is this empty value. So for example, is the double question mark, which is the nullish correlations to say, hey, if this value, this variable value exists, which is different to this nullish, undefined, or and in fact, let me actually go into this. So let me take a look now at the ECMAScript here, at the ECMAScript, because this is what really matters, bro. The nullish collisions. No, what about here? The nullish or the coalitions expressions like this, language expressions, binary logical operators. Okay, binary logical operators. This is the reason why I actually point to this. Binary local operators. All right. But if you read about this, the binary local operators, the nullish collisions, what it says is that, hey, it will allow is the coalition expression, and the coalition expression is this, is made of the coalition expression at hands, coalition expression here, so you got this coalition expressions head, which is made of this, the head, which can be either is in, yield, and await. All right, it can be precede what these values here, in, yield, and await. All right, and it's gonna do now a bitwise OR expression. In this bitwise operation, bitwise OR expression is gonna perform now this bitwise SOR. So, but in any case, so we don't go too deep into this. The value produced by this, an operand is not necessarily a type of Boolean. The value produced will always be value of one of the two operand expression. And that's interesting. And that's interesting. So let me take a look now at the nullish collision. So nullish collision in MDM, according what they describe this. So it's an operator, it's a logical operator that returns it is right-hand side operand if the left-hand side operand is null or undefined. All right. So this is not the spec, and this is the MDN doc. Okay. So again, it's gonna return now is the whatever is on the right side of the operator, if as long as if this is a null value or it is a nullish value. In other words, and otherwise return it is the left side operand as it is, right? So this is to provide some default values here. It's like, hey, I don't want to, most of the time it's to provide default value, assigning a default value to a variable. And the other is short-circuiting, relationship with the optional chaining operators. So this is one of the main use cases for this, using the nullish coalition operators and assigning a default value to a variable. That's the main use case for this, right? So main use case is this. Assigning a default value to a variable, which is good, which is great. Then we look at the nullish coalition conditional chaining, which say, hey, if the left side is, so let me check if the operand of the left side, let me check if the property on the left side exists so I can have access to the property on the right side. Okay, so check in this case if the record, check the record for nullish before property access. That's what it's doing here. Again, this is something that can introduce some confusion to your code, because at the end of the day, what happened is that you are not going, so you might confuse the reader of this code about the type of this. So that's why it doesn't recommend to go with. And honestly, I agree with what Kyle Simpson mentioned, because it's going to introduce all of these kinds of trippings and unnecessary. So you're going to trip unnecessary here. Type of grammar, here we are. Undefined null, boolean number, big int, symbol, strings. We got all of this. That's right, the empty values. There you got it, and there you got it with the nullish. With the empty values here, and there you got it. Empty values here with the nullish coalitions. The nullish and the distinct. Yeah, he doesn't. Okay. All right. Good. Then we also look at the distinguish and how now, for example, if you're going to provide as a null value to, for example, a function parameter, a default value, if you pass now null, it's going to be accepted as null. So you have to be careful about when you assign that, or when you pass now something to a function, for example, as a default parameter. You also need to make sure that despite that even you pass this, if you receive a null value, it will going to be accepted as. So that's something that perhaps is a tragedy for this piece of code to actually access, all right, and how it's going to return you null, which it shouldn't, but it does, right? So for example, greet with null, and unfortunately it's gonna give you null. So again, it's important to understand now this, and then we'll look at the special values for that, right? Such as nan, negative zeros, and the signs value here, and how nan is. Why am I putting here in this way? Why I don't? Yeah, you can talk. Yeah, we can talk about these special values, the boolean. I don't think this follow is a specific order. Exactly. It must be below that. Alright, so this is special values. When you talk about special values here, there you got it. Alright. We also mentioned the Boolean values, which is true or false, and how you can flip values using is the negated. So far so good. Alright, special guys. Okay. Alright. Good. So we pass through the kind of emptiness. We also talk about the values and the string and how the strings now are represented. I'm going to make a quick recap here because strings are represented is in using now the single quote or double quotes. And because now the way how this is represented internally by JavaScript, or aka the character encoding. So if you think that UTF-8 and if you have heard about UTF-8 or UTF-16 and this is all that you need to know, you are far from the truth, which is the Unicode and the ASCII are two different character sets where now they use different bit representations. So ASCII uses bits, 7 bits, whereas now Unicode uses this 16 bits. And the point here is to look at this representation where now the Unicode is an umbrella term for the variety of characters, such as USC2 and UTF-16, which is like UTF-16 but with little variations. However, the way of how you can define Unicode here is by you putting a U plus a following characters by followed by 4 to 6 characters here, right? So it goes through 0 to this big number here, okay? And the question is that, you got it. So it goes from 0, all right? It goes from 0, it goes from 0 to 1111 4 111 4 111, right? If you want to know what is the character code of this, we can know about it by going into this the static methods, which is something that now allows us to read this huge table that match this Unicode point value to a specific graphene or symbol. We can say from code point, okay, and please give me what is that, and this is going to tell you that. So anything beyond that doesn't appear, doesn't exist. And here's when you can take a look at some of this character as you go in here, right? It's quite interesting because most of them are like empty, doesn't look like anything, right? You might change this until you find something, some character that represent that code unit, that code point, right? So this is now a representation, all right, in hexadecimal from 1 to 0 triple F here. So because the first code points, the first group of code points are known as go from 0 to 65, 535, all right? '65 535. All right, and anything beyond that, all right, so anything beyond that number, so this first group is known as the BMP, the basic multilingual plane. So you have now all of these basic, most common useful characters, which is used 16-bit to represent that. But anything that goes beyond that, all right, known as the Astral Plane, it is made of 260 bits adjacent, known as the surrogate pair, that allow you to represent is more symbols, all right? So particularly it used 21 bits to represent that. So if, for example, we say, hey, what is this symbol? You know, what does the symbol look like? For anything that go beyond that, you can say it's 75 or 30, you know? And they might going to tell you is some characters here, so encoding characters, some of them are not visible because they must use some so your the string table might not have that represent in your local. That's another one, but in any case, doesn't get into the detail. But as you can see, it allows you to represent is those. So from code point, look at this string from code point. It only allows you to show anything that is inside of this. So code point in English, exactly, is less than 0 or is greater. So anything that is go beyond this, all right, which is in Unicode, is going to throw you now a range error, which is you pass, for example, this code, is going to throw you now a range error. So here, higher code points are represented by a pair of 16-bit surrogate pseudo character from code point. It may return the string length, if that in UTF-16 code is larger than this. For information to this character point, this is how you can get that. From code point, so as you can see, it's starting to give you now is some additional or special character that some of them might be represent or not. All right. Again, you may wonder why it shows you now this square icon. Might be depend of the string locale that you are using. That is not something that it can render this. All right. So, but the whole point of this is that we can now represent is this symbol character using this. All right. Can now represent is this escaping characters to show you this. So from this particular range, or from the range that I mentioned, from 4 times 4, from 0 to 4 times f, it is known as the basic multilingual plan. So in other words, if you see this is the last element is going to represent. Okay. Until this. So this is now all of these basic characters here. And then you can play with this to see what's going on, right? You can play with all of these characters to see what's going on. And right, give you now, it also have now some words in Arabic language, all right, or in Chinese character. You know, it is including is it is an extension of the character beyond the English alphabet. Okay, so I think this is quite interesting and important to understand, because now if you want to represent anything beyond that, known as the astral plane, you have now this surrogate pair, all right, which allow you to represent is those character set, because the way how they are represented is using the 16-bit in JavaScript. Now count symbols is not the visual way we do, but by graphenes or symbols using this representation of the 60-bit. That's why now, for example, if you're starting to use emojis, all right, the internal representation of that, all right, is now a composition. It goes beyond the basic multi-language plane. So for example, if you do this and you want to know the length of this, all right, so it's gonna give you this too, because now it's using these two graphenes. How do I know that it's using that? Because if you split that and then you want to know what are the Unicode points values, it's gonna tell you that. If we take each one of them, okay, we take each one of them, and then you combine them, all right, they is going to internally JavaScript say, okay, these graphenes combines represent this. If you now use only one of them, all right, it's not going to tell you nothing because it doesn't mean anything. This single code unit doesn't have any representation of this astral plane. So there are also is more interesting and challenging questions. That is, hey, what happened when you, for example, look at this, right? There's now a specific including icons. So now it say, hey, it represents 4. It means that those Unicode points is using the combination of 4 of these Unicode points. So in other words, it's doing this, right? That's a good interesting question about what is the value of this. Okay, what will be the value? Claudia, how can we determine is the value of the char code point value of this based on the Unicode point, based on the Unicode point of doing this operation. Elements in the module composed of multiple Unicode code points. Exactly. Here's how to determine the Unicode point value of this. So you say, hey, you're gonna get each one of those characters, all right, and for each one of them, I want you to get the code points at that position, and then you're gonna get all of these code points, all right, which is describing is this, and there you got it. So this is the Unicode point, right? So if we take a look now at this, we say, hey, this actually represents the length of 4, all right? So 4 characters, which is good, which is what we want, we know. And then we want to iterate through each one of them, all right? We want to iterate to each one of those characters, get the point code at that, and therefore print that, you know? So this is now the character at that position is this, which doesn't mean anything, but is the code point of this, right? There's another one, there's another one, and there's another one. And when they combine together, all right, when they're combined together, they have now meaning too. Exactly. Okay. If you want to know, for example, is now the decimal code unit point, all right, what you're going to do is to iterate through that, all right, or transform into that, and then I want to know is what is the number values that it belongs to, or the decimal value that it belongs to. So you can do is this, Alright, if I want to know the decimal value of this, I want to use now the spread operator that say, hey, I want to create now an array of each one of those elements that are made of. And now you can use a map or a for each to actually iterate, but the thing is that I want for each one of those characters, right, I want to give you now is the character code point at that position. All right, and then it's gonna give us now these two numbers. So if you're trying to look at this number, let's say if you say, hey, what is the number from code point? Exactly. So what is the number? What is the value of this? It's gonna look at that hash table and say, hey, this is the value. And what is the value of this? All right. It's like a dark tone. I don't know why this doesn't represent, but it is a dark tone. So when it combines now those dark tone with the light and the dark tone, now it say, all right, it makes a lot of sense to use that, to combine this. But there is a distinction between is the code point, okay, the Unicode points, all right, that is made of that combination, okay, it's pointing to Unicode points, bro. It's pointing to Unicode points, bro. So again, the example here is to say this is dot length. All right, all you want to know is what is the value inside of this, which is here. But if you want to now take a look at what are these individual Unicode why not? Exactly. Oh, if you want to know is what is this made of, this split, so it's gonna give you now is this Unicode point, but in the combination of these Unicode values, Unicode point values. Okay. So the thing here is that this Unicode point, right, it is the hexadecimal representation or the Unicode representation, even though it's telling you that, the Unicode representations of these particular characters. So these Unicode representations, all right, because individually they don't mean anything, but when you combine them, it now belongs to a particular number, all right, on this table. That, for example, if you want to take a look at what is the char code of this, it's a map here, all right, and you want to know is what is the char value of each one of them, you say char code point at, right, and it's gonna give you is these individual values, right, that individually they don't mean anything, but combined they now represent is a particular character. So for example, if you say, hey, what is this string from a code point, right, of this value, first value, what will be the expected output here, right? What will be the expected output? Exactly. It's gonna give you now the Unicode. It's gonna give you the Unicode. So you expect that to give you is the icon? No. So for example, if you use something like this, to actually is now representing is those unique values, or in other words, is this with this another value here. Now when you combine them, they actually now points to something, right? So the whole point of this is to understand this astral plane, this adjacent, the BMP, the basic multilingual plane, as well as the adjacent surrogate pairs, and why we are using that and why we need to look at this, and how now, well, Twitter decide that the length of all icons, it'll be 2, which is quite counterintuitive, because for the human perspective, any character looks like 1, but in any case. So again, this is a particular nuance that you need to handle, especially for handling is emojis and that kind of stuff. All right, and then which is important to at least understand that there's some other interview questions that are quite powerful, I will say, to look at this, which is what is the length value of the emoji. This is the length value of this emoji and why it is 2. All right, and the other is now the behaviors of the string. So for example, a string character access, how you can access to, similar like an array style. The other is how you can iterate through a string, whether it's using a for or using the for of loop. All right, where now the string internally has a known symbol, which is, you can think of symbols like hidden properties that allow you to access some custom hooks in some objects, right? So for example, here, all right, you can now have access to that string. Let's actually look at this example. We can have access to this string earlier, all right, and because internally it has now this particularly hooks, so object has allowed you, so with symbol it allows you to access hidden properties of a specific object that has some custom hooks or some behavior that allow you to do this meta programming. Okay, so for example, I can say, hey, from my name, I want to say, I want to say, do something like this. So from my name, that I know that this has some hidden property that I can have access using the known symbols, which is with symbol dot iterate iterator, all right, and I want to now get that value, all right, I want to access to that property, which is now an iterator, and anytime that I invoke that iterator, I can have access to that particular behavior. So iterator.next, this is because I am not getting that properly. Yep, I didn't assign that properly. Exactly, now I have the string operator, okay, and then I can now say this one. So I can have access to this internal private methods and give me now those values, anytime that I call it. And once that is done, it's give me done true. This is quite powerful because now there are some known symbols or known behaviors in a specific object that you can have access and you can get benefit from that. Why this is important? Well, because sometimes, so in the case of strings and the iterator, it allows you to understand now how you can iterate through this data structure, as a string, as an array-like, all right? Using that for of instance, and you don't have to worry about the length of that, all right? You're going to traverse that. So if that length, of course, is huge, well, it's gonna take some time to handle that. So that's what interesting, the character iterations, all right? And then the length computation, which is something that I mentioned before, and there's some character set that actually are now represented double, all right? So for example, if we say here, again, if we say now, if we say, for example, this, all right, and we want to add the length for this, well, we say that, hey, this is now 1, which is good. But if we say in here, oh, it seems that they fixed that. It seems that they fixed that behavior. It seems that they fixed that behavior. It seems that they fixed that oh no, they don't. Okay, for variables stored into that is not interesting. So if for variables that you store in for string variable store, it now have this. So if you want to, for example, normalize both of those string, all right, which is something that they call about NFC and so on and so forth. Let's take a look at this. If you want to normalize this string, character iteration, strings, internationalization, notice this. If you want to normalize this, exactly, such characters will be counted in the len. All right. So, for example, if we say and then we want to get now is the split to actually see what is made of this. He said this is only this character, all right. But when you combine this, or you say, hey, what is a chart code this, it tells you that is this. But unfortunately, we still have some possibilities of the character of code points greater than this. So for example, so teléfono, all right, for example here, teléfono, separately the length is this, all right. But there are some characters, unfortunately, there are some characters here that when you want to have access to this and compare the length, now it gives you that properly. Okay, it gives you that properly. Good, good. All right. But sometimes it's give you not this length. So unfortunately, they still need some normalizations here that needs to be done. To get closer to an expected intuitive graphene length for a string, the string value first needs to be normalized with normalized NFC, normalizing Unicode in chapter 1, to produce any composed code units where possible. In case any character were originally stored, decomposed, and stored as code units, a separate code unit. So in other words, you want to store this item here, and I want to store favorite item in a normalized way using the NFC, and when I check the length of that, is now 8. Holy moly. Okay. Normalization. Multi-character escaping and Unicode normalization. Another wrinkle in Unicode string handling is that even certain single MVP characters can be represented in different ways. For example, the E character can either be representing itself as code point 233, aka this and this, or this. Okay. Or as the combination of two code points. The E character code point, aka this, and the combining title code of this. Consider this. Okay. A very edge case here. Both of them are give you this. The string literal assigned to E till 3 in this snippet store the accent mark as a separate combining mark symbol. Like surrogate pairs of combining marks, one makes sense in connecting with the symbol it is adjacent to, usually after. The rendering of the Unicode symbol should be the same regardless, but how the E character is internally stored affecting things like length computations of the containing strings. Exactly. So if you check now the length of this, or the one, it's the way how now it is storing it. This one particular challenge is that you may copy paste a string with E character visible in it, and that character you copy may have been in the composed or decomposed form, but there is no visual way to tell, and yet the underlying string value in the literal will be different. So even though if you do something like this, it gives you false. This internal representation difference can be quite challenging if not carefully planned for. Fortunately, JavaScript provides a normalized utility method of strings to help. Interesting. So if you do, for example, this, and then you say normalize here with NFC, and then you say normalize to NFD, the normalization is different. The NFC normalization mode combines adjacent code points into the composed code point if possible, whereas the NFD normalized mode split a single code point into its decomposed code point if possible. Decompose and compose, and there can actually be more than two individual decomposed code points that make up a single composed code point. For example, a single character could have several diacritical marks applied to it. When dealing with Unicode string that will be compared, sorted, or length analyzed, it is very important to keep Unicode normalization in the mind and use it where necessary. Unicode graphenes clusters. A final complication of Unicode string handling the support of clustering of multiple adjacent code points into a single visually distinct symbol referred as a graphene. Okay. A final complication of Unicode string handling is the support for clustering of multiple adjacent code points into a single visually distinct symbol, referring as a graphene. So a graphene here means is this composition of several of these code points to represent one symbol. As an example, will be the family emoji such as family, which is actually made of 7 code points that all cluster grouped together into a single visual symbol. This emoji is not a single registered Unicode point, and such there is no normalization that can be performed to compose these 7 separate code points into a single entity. The visual rendering logic for such composite symbols is quite complex, well beyond what most of JavaScript developer wants to embed in our programs. Libraries do exist for handling some of this logic, but they are often large and still don't necessarily cover all of the nuance variations. So you say, what is the length of this? Now the length of this is 11. Holy fuck. Holy fuck. But unlike surrogate pairs and combining marks, the symbol in graphene cluster can in fact act as a standalone character. But has the special combining behavior when placed adjacent to other. So for example, if you do something like this, it's gonna say, hey, this is true, which is good. But if you want to combine now this, it's gonna give you this is true, but you gotta be careful is how those are now stored here. And I think that this might go beyond the scope of this, where now the TLDR of this is this. When dealing with Unicode strings that will be compared, sorted, or length analyzed, it is very important to keep Unicode normalization in mind and use it where it's necessary. Okay? Do this nature of how the strings are represented. So I think that that'll be a good tangent here, a good way to describe why we're doing this kind of stuff and so on and so forth. So I think that'll be like that. Absolutely. So, yeah, there's some topic that go beyond the scope of this. That is not worthwhile to analyze. Just to keep in mind that anytime that you need to do some comparison, sorting, and anytime that you need to compare, sort, or length analyze, or the length need to be analyzed. Okay, it is important to keep Unicode normalization in mind and use it where necessary. Okay, so anytime that you need to compare string, okay, anytime that you need to compare string, whatever string might be, all right, anytime that you need to compare string, you say normalize. Using now is compose or decompose form. All right, the normalization mode combines adjacent code points into composed code unit. So you say, hey, I want to now compose those by saying is Jesus. So for example, this, all right, and then I compose this. I want to normalize using the compose form. Okay, I want to normalize this with an n, with the compose those code points. Okay, combines adjacent code points into compose code unit. Okay. Combine adjacent code points into compose unit. Okay. And if you want to know the length of this, it still give you 2, but during the comparison, is going to now handle that. But this is a very edge case here. A very edge case here. And a very edge case here. Normalization. Normalization. Unicode normalization. Interesting. Okay. Unicode normalization here. The Unicode normalization here. The Unicode normalization here. All right. Yeah, the Unicode normalization here. Okay, I think this is the TLDR of that, the code normalization. Then we look now at the internationalization, the other topics here. Yep. All right. The other topic here, the exactly the string comparison. All right. Yeah, that we talk about this, the string comparison. The length computations, the normalization, all right, and the internationalization E18N and localization E10M. The TLDR of that is internationalization. Allow you to, for example, using the locale, compare words in their alphabetic order, whether it is on German, English, Spanish, Farsi, or Chinese. Based on those lexicographic analysis or sorting, you can use now the internationalization to say, hey, I want to compare now words in that by saying, let's say, German string sorter, okay. So German string sorter, I do this because I want to create now from the internationalization, okay, the collator to indicate what will be is the collation of these words, all right, or this range of this alphabet. Hey, I'm gonna say, well, let me do this in Spanish, right? Okay, and then I want to get is the German string sorter, all right, and then I want to it expose now several methods. One of them is compare, all right, where it say, hey, internationalization API, do based on your set, okay, based on your alphabet set in Spanish, is this word the same as this word? All right, if it's 0, it means that they are the same, all right. If it's 1, it means that it's greater, all right. We can also say, hey, collator, well, I put the German, but actually it's Spanish. I can say, hey, Spanish string sorter, hey, I want to now provide some options here and say the internationalization alphabet that I want to use to compare here is Spanish, and let me pass some additional options here. So for example, is that case first, okay, case first, uppercase, upper, right? And here, if I want to, for example, now compare that Spanish string sorter to compare some vowels and say, hey, what about this? Are they the same? Are they the same? And it tells me -1, negative numbers. Interesting. And it says this one. Is it the same here? Or if it's not. -1 or negative numbers. Okay, but again, this is what you can do with this, with the collator and the segmenter. And pass the compare function of this. So I want you to sort all of this based on this. But again, it's going to sorting is based on their language sensitive string comparison. It's going to give you -1 if the first is greater or is in a less position, okay? Or if this is going to give you positive is the first is further in alphabetically, okay, or the same if both of those words are the same. But this is quite interesting, and we're using this just as a way to say, hey, when you need to, for example, compare strings in a language, all right, if you want to sort, because this is something that is widely used, if you want to sort elements, or if you want to sort phrases or words per language, we have now is the internationalization API that allows us to handle those cases, all right, and sorting alphabetically in their specific alphabets. Okay, all right. So I also create now a particularly demo for that, right? That you can take a look at that, right? And how you can do this multi-comparison language, all right? I think that's quite interesting. This multi-comparison language, you know, text 1 comes before text 2, right? It is comparing now using is the N letters, right? The other is to multi-word comparison or sorting. I will say that this is more like a sorting. Okay, multi-language word comparison. Texts now are equivalent per language, and the same for this. You know, interesting. And the other is a segmenter. Segmenter is when you need to analyze a text, a body of text, and then you need to get each one of those meaningful words. The thing is that it doesn't give you now is the emojis. So in this particular case, we force is, we can even inspect the code here to look at that. In our case, we force, because everything is here. Oh, this is Grammarly. The script, we put everything in here because we just fix the emoji here, and we say, hey, if this belongs to this sequence, all right, therefore it belongs an emoji, all right. So you're gonna now render that element there. This pretty much is this. So that's great. That's fantastic. Absolutely, absolutely. And then, well, we went through what we really care in today's video. This is to move on with the primitive. Now we're still looking at the numbers, string, you got it. String concatenations, all right. Where now this is preferred method of doing that. String concatenations. This is another position. I think this is something that we are quite familiar with. Something that we don't need to dive too much into this, the string concatenations. Why this is helpful, why it is important to at least understand, right? And the several ways of doing the string concatenation. Whether it's this or this. Or this, using the interpolation template string, which is template string. Okay, so far so good. And then the string values method. So we are quite familiar, we're getting ourselves familiar with that character at that position. Produce a new string value the numeric index of that. So for example, you say, hey, what is the character of Eulier? Right? Eulier, all right. So what is the character? What is the character at this position? Say 3, and it's gonna give you that, right? If it doesn't exist, well, it's gonna give you that. So character at and at is similar to character at, but negative index count backwards from end of the string. That's interesting. So you can say, okay, so negative integers here count here. Say at -2. So I'm counting in a reverse order. Right? Good. It's not gonna give you that. Exactly. It doesn't work for this string value methods. String value methods. Char and char at. Okay. Char allows you to use now negative index. Okay. This is one of the reasons why a lot of people. This is when people fail, because they don't understand is the primitive, this fundamental aspect of the language, bro. And I get it. And I get it. And I get it. And we're back. So this is quite interesting, because this kind of stuff that we're looking at here is something that I know that a lot of people actually they don't know how to work with this, you know. And this is pretty much like if you have a wrench, or you have a nail, or you have a hammer, you know what this tool is doing. This is exactly it. This is what the primitives is so important to understand. This is the wrench, the spoon, the fork, and all of this that allow you to, well, work and eat. Work and eat. All right. This is the primitive, and this primitive, all right, have now these specific behaviors. And it's important to describe that. Absolutely. Oh my God, absolutely. All right. Oh, I think this is something that is worthwhile to create a small website to see how all of this is working. All right, to see how all of this is working. So we char add. It now produces you a new string at the numeric index, similar to get that from specific values. All right. If that value is out of reach, then of course it's not gonna give you that. It's gonna give you an empty string. All right. However, if doesn't accept you is negative values, unlike the char, unlike the add. So add now say, hey, you can start from the left to right or from the right to left, whatever you think it fits. All right. And in my case, it's quite interesting because that's the same. You know, -4 or 4. You see, it's like, hey, you can start from end to from right to left or left to right. The other is the now familiar method, which is char code at that position. What is the char code at that position? And this char code is now the numeric code units. See the JavaScript encoding in chapter 1 at a specific index, which is the Unicode index. All right. No, this is not the char code. Char code at what is the Unicode index at position 0 or 1 or 2 or 3 or 4 or 6. You know. What is the numeric code unit? So for example, if I say now here like this, all right, and if I put this here and here, right, what is the char code at -1? Unfortunately, this doesn't accept is negative values. So that's sad. That's sad. This char code at is gonna give you now the number of that code unit. It's gonna give you now the number of that code unit. Okay, which is great. The number of that code unit. The other is the point, the code point of this. It's a code point at that. In this case, 0. And the other is the numeric representation of this. Returns the whole code point starting at a specific index. If a surrogate is found there, the whole character point is returned. Exactly. If a surrogate character is found, the whole code point is returned. The other is the code point at, code point, or the char code at this one. So one of them is give you now the numeric, the decimal point. Exactly. One of them give you is that the integer of that. Exactly. Returns the numeric code unit of this. And if you want to know what is the Unicode values, it's gonna give you this. You know, look at this. This is made of now of several Unicode points, right? And they go give you the string followed by the other Unicode points, right? There is something that I don't understand here, and that is the difference between the char code and the char code at. So what's the difference between chart code and code point at? Is how handle Unicode characters, especially those outside of the basic multilingual plane. So chart code returns the UTF code unit 16 bits. For characters outside of the MPP, it returns only part of the surrogate pair. Older method doesn't handle modern Unicode well. And then you have now the code points, which return the full Unicode point up to 20-bit values here, which is this. Properly handled all Unicode characters, including emojis. And newer method EX6 recommended for modern Unicode. So the difference, and this is important to understand this difference. The difference between chart code and the code point is that now chart code return you or give you is chart code. So chart code give you is the characters that are represented in the basic multilingual plane. Anything that is from the range to 0 to 65535, or in other words, in this 16-bit representation of, is gonna give you that. If that character is made of if that characters go beyond this range, is known as the Astral Plane. They are now combined or known as the surrogate pair. All right. So you have, for example, is the thumb down that is now made of these two surrogate pairs, or even now more complex scenarios where these surrogate pairs are made of pair of surrogate pairs. So for example, in the case of flags. And why this is important? Because these two distinct methods, the first allows you to recognize is basic multilingual plane, all right? Whereas the second allows you to recognize all the Unicode characters, all right? Whether it's on the basic and the Astral Plane. And I get it why they mention basic and Astral Plane. So the TLDR of this is, most of the time we prefer to go with the code point at to work with that. Because this will give us now is the meaningful character that when we want to know what is this or what this number means, we can have access to the static method called string.fromCodePoint, all right, and now get that from code point. Interesting. From code point, and the other is from chart code. But from code point, which give you that, but it's gonna give you now is the single unit, right? Returns the whole code point starting as a specific if surrogate pair is found, the whole character point is returned. Does not. From code point to code point add. That's interesting. And when you combine these two characters, this one with the other one, exactly because it is made of that. But that's interesting because this is gonna give you now is this surrogate pair, all right, or allegedly. Exactly. Code point add for modern applications, especially when dealing with emoji or international text. Exactly. If I want to get the value of, and then based on that transform into the flag emoji using this string dot from char from code point, how can I do that? Of two regional indicator symbol letters. Exactly. So this is exactly. Exactly. So this surrogate pair is now a composition of both of them. It's a composition of both of them. Okay. So it is a composition of both of them. Interesting. Interesting. It is a composition of both of them. You know, but here is giving you is this not surrogate. It's giving you is the Unicode representation of this. It's giving you the Unicode representation of this. Exactly. It's giving you the Unicode representation of this. It's giving you the Unicode representation of this. Exactly. The Unicode point range here, which is this 16-bit, is gonna give you is what JavaScript sees as a length, whereas a Unicode point here. Okay. So because this emoji is not visually seen as one, and if you want to know the length of this is, you want to know the length of this is 4, it means that the way how this graphene or symbol is represented is using a string, using a UTF 16 bits, using a two pair of adjacent, using a two pair of surrogate pairs. In other words, is using now is fourth 16 bits to represent this character. So why this is important? Well, because if you want to know is the character point at that, all right. So for example here, if you want to know the character point, or if you want to recreate now whether if you store that into but I think most of the time this will be stored as it is, so you don't have to handle that, right? So you can say is thank you. Okay. You can now store that in your database. You have to be careful of how you are storing this. That's why in database it is important is the character set that you're storing stuff. So for example, UTF-16, all right, or this Unicode, because now it's going to behind the scenes allow you to store this without having to worry of all of this intrinsic nature that strings is after all. So the TLDR of this is that the difference between char code add and char code point add is that char code add gonna give you is so for example, if you say something like this, char code add code exactly char code add is gonna give you now exactly 0 1 2 3 4 exactly. So, but it's gonna give you now in a so character code is gonna give you now is the code point in this single BMP plane of that, and the other is gonna give you the surrogate pair if they are. Okay, char, which is code point at is gonna give you the surrogate pair of that. So that's a subtle difference between the char code add and the char code point add. Is a way of how they're going to give you this representation of this. In other words, use the code point add to detect that. However, if a surrogate pair is found there, the whole character point is returned. So for this, but because this is now if you want to use a string from code point, it's going to give you now is not the surrogate pair. Ah, yes, the surrogate pair, bro. But in this representation. So in any case, use the code point, the from code point. Use the code from point. Okay. The other is subtract, substring, and slice. Produce a new string's value that represents a range of character from the original string. This difference is how the range start ends in this specify or determine. So for example, given the same string before, we say, hey, substring, give me the substring from 2 to 3. All right. You have to be careful of how you're going to get that, especially with characters. Especially with character of this surrogate pairs, because it's giving you now the surrogate pairs of this. That's what it is. That's why it is important to understand this. Substring or substring is the same as well as this. Substring, or slice. All right. Produce a new value that represents a range character from the original string. This differ in how the range start and end index are specified or determined, right? You can use it as a substring or the substring or a slice to get a slice of this. If you say, hey, I want to say, hey, other method like to uppercase, so I want to put all of things on uppercase, or to lowercase as well, or to say, hey, use now the browser default language to put that as it is. So to locale lowercase, or to locale uppercase, right? The other is the concat. You can easily do that to say, hey, I want to concat is with this another string. Okay, with this another string. Yes. The other is the index of. To get now is the string value argument at that position. You say, hey, the index of search string and that position. So search for a string I, and then now give me is the position, all right, which say that this is 7. And if you count now here, you don't see that actually 7. You see that this is 1, this is 2, 3, 4, 5, and this is interesting. This is a very interesting question here. This is a very interesting question. You can say last index of or index of, but from the end of a string, similar to at, that can handle its negative values, all right, to get that, which is at 1, for example, 0, but it's going to give you is that character. It's going to give you that character, and it's going to give you the Unicode value here. It's going to give you that Unicode value here. That is this representation of these basic simple plane values. The other is includes. Okay, so you can say is with index of, so search from this, search this term here, and give me now the position of that. Okay, search string and the position index of, all right, and again it's gonna give you, say, hey, this is now made of 2 surrogate pair, aka I'm gonna count this as 2, this is 3, 4, 5. Because this actually count is like 4. Except for 0 to 3, it's like this emoji is counting is in 2 surrogate pair, all right, or in other words 4 in other words is 16 bits, where each 16 bits represent is 1 character. So 1, 2, 3, 4, because it starts from 0, so you say 0, 1, 2, 3, and you have now 4, 5, 6. You have to be careful here. You have to be truly careful of handling this. Okay, that's very, very interesting, and you have to be careful of that. This is good because you say, hey, we found this in this position, okay? And if order is something that matters to you, you need to know that this is something that can happen. So the TLDR of this is you're going to handle is emojis or anything that goes beyond the basic multilingual plan, okay? Anything that goes beyond this 16-bit representation, that is something that JavaScript count that as a character, okay? And if you want to represent now more than that, there's some elements that can. There's some elements that needs to be represented. Is if you want to represent elements beyond that, JavaScript now put two 16 bits adjacent to it, specifically 20-bit, 21 bits that is used. But it puts now these two 16-bit adjacent known as surrogate pairs that allows you to represent is this astral plane. These elements that go beyond the basic multilingual plane. Holy moly, bro. Holy moly, bro. Okay. That's interesting. Concat index of is going to search from that in a linear way. The other is include as well. Include to check if that actually exists or not. Okay. The other is actually search, similar to index of, but with regular expression matching as specified. If you, for example, only use a sort without passing any argument here, it's gonna sort in an alphabetic way based on their locale. Okay. Is include, sorry, is the search. Is search. Is search for this, but with regular expression. With regular expression, you can say, hey, please find anything that starts as an A to C. You know, and then you can pass any regular expression to that. Or search by this, you know. The other is trim, to actually trim start, trim end, or trim. So for example, you have now empty space. It's gonna remove those empty space. Say trim of those empty space. All right. You can also say, hey, repeat this 3 times, the number of that, or repeat this 3 times. All right. And then after that, I want you to now trim the output. So remove the trailing and the white space here. So the trailing and ending white space. All right. You can also add padding if you want to. Pad star to say, hey, this is 2 or 3 or 4. You know, it's gonna produce now. You say, hey, I want you to add padding or produce a new string with values. Padding, default white space, but can be override. I want to say, hey, I want to fill this with zeros, for example. Hmm. Pad star. Pad star. Pad star. And pad, perhaps I wrote that, pad n. That's interesting. It doesn't add that. Produce a new string value with padding default white space, but can be override applied to the either start or the end. So the final string result is at least of the specified length. Oh, okay. So the end string will be now padding of that. Makes a lot of sense. You say, hey, the max length of this will be now this. Holy moly. Padding in or padding? That's interesting. Padding in. Padding in or padding? Interesting. Padding in or end padding? And then you can specify here is that, you know, you can specify, hey, I want to add now this number, and this will be the length of this. Let's say now 6, right? So hey, you just want to represent is now, this will be my, say, ASCII length, you know, second. So the ASCII length is this. That's interesting. And you want to check that. Or yeah, you can say, so the ASCII representation, you know, and you say you want to access to that ASCII representation, and then you get it, right? And then you can modify those bits as you see fits. That's interesting. Or the other is, well, now cons Unicode representation, and here you say, well, it's going to start now padding star or n is indistinguished, but I want to be is now power in 2 power 3 is 4 exactly. 2 times 2 4, 2 times 2 8, and 2 16, and this will be now the values that you're gonna have, right? There you go. And then I want to know what is the Unicode representation. Unicode representation, right? Holy moly, I think it creates too much. Oh, it's because, yeah, it creates too much because it's 210. Is add like too much? Why is that? In notation. Oh no, my bad. It's like 2 power 4 And there you got it. Exactly. Because the other is that this elevated to, well, that. Exactly. Produce is now 20,000 of this. And here I just want to create is only 16, you know? So all of this is just as a way to, well, get yourself familiar with. Start with, end with. This is to check if that match for an irregular expression. And replace, normalize, local compare, and then you have other ones. Anchor, big, blink, bold, fix, font color, font size, italic, link, small, strike, sub, and sub. Historically, these were useful in generating HTML string snippet. Now they're deprecated and should be avoided. Many of the methods described above rely on position indexes. As mentioned earlier in the length computation section, these positions are depending on the internal content of the string value, which means that if an extended Unicode character is present and takes up 2 code unit slots, that will count as 2 index positions instead of 1. Failing to account for decomposed code units, surrogate pairs as graphene cluster is a common source of bug in JavaScript string handling. Failing to account for decomposed code units, surrogate pairs and graphene cluster is a common source of bug in string handling. This string method can all be called directly on literal values or on a variable property that's holding a string value. When applicable, they all produce a new string rather than modifying the existing string, since strings are immutable. Exactly. So static strings helper from chart code and raw. Okay, so I think that'll be all for this video. Take care. Bye bye.